Hello, this is George Fahmy, the founder of Stackpack. Today we're going to configure GitHub Actions to be able to apply Terraform code by properly setting Terraform remote state, then allowing GitHub Actions to apply code, then make this whole thing reusable with Terraform modules. So to start, we're going to have to give GitHub Actions access to our AWS account, and the best way to do this is to use an OIDC provider. And there is a module that already exists that helps us do this. So let's look it up. It's this one. Okay, so we'll call it GitHub provider. Yeah, open it up, check the documentation. Okay, so we need to set the repository name, the OIDC role to attach, and create a provider. Okay, let's copy all of this. Perfect. So we're going to give it administrator access. Let's save this first. And then it's probably a good idea to limit the access of the GitHub action, but since we don't know what exactly we're going to apply, so just give it administrator access. But be careful to limit this in production. Okay, and then we save. And these are the repository we're going to create. So let's extract this into our variable. TF repository. Made a mistake. What mistake did I do? Okay. So we extracted this into a variable. Actually, let's turn it into a list. So you can add more repositories in the future. And save. Okay, so now GitHub Actions, when I apply this, GitHub Actions will be able to make changes to our AWS account. So the next bit would be to create an S3 bucket, which stores state, and a DynamoDB to log state. So multiple people can apply Terraform changes at the same time. So let's look up a bucket. S3 bucket. Create a bucket. Where is it? Yes, here's the bucket. Okay, so let's call it df state. Let's name the bucket. My TF bucket. I thought I had a name. Does not have property. What did I get wrong? Check the docs. Bucket. Okay. So let's copy all of this. So let's add some tags for best practices. This allows us to be able to easily grab on Terraform AWS resources and know which environment, which team they belong to. So now we'll add a dummy tag called Terraform to know it belongs to Terraform, and that's it. Okay, I think we should. Yeah, let's extract this into a variable as well. TF state bucket name. Okay, looks good. So let's check the next bit. So yeah, we need to apply versioning and a prevent delete lifecycle flag because you don't want to accidentally delete your Terraform state. So let's see how we do this. Check the documentation. There's something about versioning here. Okay, yeah. So there was a versioning option, but it's now deprecated. And instead we should use this resource. So let's look it up. TF state versioning. So to set up the bucket name. Save. Then check the docs. Need to enable versioning. Yeah, so now we have the bucket where the state will be stored and enabled versioning for this bucket. Let's see what else we're missing. The DynamoDB for state locking. Okay, so we need to create a DynamoDB table to use it as a lock when people are applying Terraform, so you can make changes at the same time. Like, I don't remember how to do this, so let's ask the studio to help. So DynamoDB bucket for TF state lock. Let's see if it's able to generate this. Okay, so I created an AWS DynamoDB table that's called TF state lock and an AWS provider block, which is fine. Like, we needed this anyway. Let's accept the recommendation, check the code. Does it make sense? Okay, it's called created column like called lock ID, which means we need to do this. The hash key. Perfect. Let's change the app, Terraform as well, and reuse the bucket name variable. So everything is well organized. Okay, cool. So let's double check the steps. So now we have an S3 bucket with versioning. Now we forgot to prevent delete lifecycle flag. So let's do this now. And a lifecycle and prevent destroy, set it to true, so don't accidentally delete our Terraform state, because it's very difficult to import Terraform state all over again. Okay, so we create the state backend. Let's turn to the module. So to turn to the module, we want to make this reusable. So let's see like which fields exactly we can reuse. Let's go over here. So we already parameterized the bucket name and the TF repositories we use. We can parameterize the region as well. So let's check this here. Extract it. AWS region. Refresh the code. Okay, so the region is also parameterized. One good thing to do is also, like, if you're juggling between different AWS accounts, you need also to parameterize the profile. As in my case, like, I have multiple profiles. So let's create a new variable. Call it AWS profile. So we're able to switch between profiles, like apply code for different accounts at the same time. Let's add a default. U North 1. Let's use it over here. Profile variable AWS profile. Save this. Okay, what else can we parameterize? So the AWS profile, AWS region, the bucket name, repositories, unlock, versioning. Yeah, I think that's good. Let's refresh, like, organizes things a bit. Okay, I think it's good. Let's try apply it and see if we messed up anything. So turn it to a module and then, yeah, actually build a separate, like, make that region and profile configurable. Okay, so we should be able to publish this in a module. So let's do this. Publish Terraform module. We need to add a tag so we can refer to this version. Let's add it. What's wrong? Maybe I have like the same version on another project or something with the same name. So let's create a version. So now that since we have a version, we can use this as a module. So let's try do this. Switch over. Terraform AWS setup. Instantiate this module. Why is this messed up? Okay, it's fixed. Okay. Let's see the variables we got. We need to populate. So AWS profile, AWS region, TF repository, and TF state bucket. So let's set up AWS region. Ah, smart. I love Copilot. And AWS profile. My profile is called bubblegum. And then TF repository. Actually, this is now like multiple repositories. So we should call it repositories. Okay, great. So the cool thing about this is like it automatically like updates the variable because it's like I changed the reference. So repositories, and add my GitHub profile and the demo repository. Now TF state bucket name. This is important. So TF state bucket name. TF state bucket name. I actually forgot something very important. So here we didn't specify like what the role name is for the role created that would be assumed by the GitHub Actions trying to apply Terraform. I think there was a field about the role name over here somewhere. Oh, this is tiny. Role name, yes. So let's add a role name. Extract this to make it parameterizable. TF role name. Perfect. So now we also have a TF role name to populate. Save. So let's try using this. Terraform init. So it downloads the module we just published. Come on, slow internet. So what should we do next? Until it's done, we should test it. Can actually create a new folder here for running the test and add a new file. It's done. Cool. So let's apply it. Terraform apply. This will create the bucket. So let's see what this will create. So this will create the TF state lock, DynamoDB table, create our bucket, and enable bucket versioning. Then add the module, and this module is going to create a policy that allows the GitHub OIDC through its GitHub OIDC provider to create this role for Terraform to use, and this role has an administrator access. So GitHub Actions is able to apply Terraform with this role that allows it to create anything on our AWS Cloud account. Let's apply it. It worked. So now our state bucket is created. Let's test it. So here we have a snippet to run these tests. Let's see if it's able to connect to the bucket and create it. So let's set the bucket name. What was the bucket name? Yes, here. Copy it over. In the region, EU North 1, profile, bubblegum, and the DynamoDB table was named exactly this bucket. So let's switch the test. Terraform init. Awesome. Connected to the bucket and it's working. So whenever we want to create a new module and want to refer the bucket, we can just like use this module to create buckets or like parts of the bucket for different projects. And then this creates everything we need to apply Terraform remotely through GitHub Actions. And whenever we refer to this bucket and create a GitHub action that assumes this role connects back with the same repository name, then we're able to allow GitHub Actions to apply this code. And thank you. That's it. You would find a link to this code. This is public, but I'll share the link so you can just export the code or make changes to it on your own. And yeah, that's it for today. Bye bye.